For number 1, we have 3 correct answers. These are all talking about dilations, and remember, dilations are like looking at a picture on your phone where you can pinch it and make it bigger or smaller, and it never changes the perspective of the picture, right? The picture itself is actually not changing, it's just changing its proportions. So keep bearing that in mind. Our correct answers for this one are number 2. Perpendicular lines are going to be perpendicular lines no matter if you're dilating it to be bigger or smaller. It's also 3. Your angles are going to be congruent to the original angle. Remember, congruent means equal. So imagine you had a picture of a square, right? And then if you pinched it and made it bigger, those angles in the corner are still 90 degrees. It doesn't matter how big or small you make your square, it's always going to be 90-degree angles in the corner. So the third one's wrong because, like we just said, the angles don't change. And let's see, it's also the last one. The dilations, the triangle is going to be similar, not necessarily congruent because that means they would be exactly the same size, but with a dilation you can get bigger or smaller. All right, for the second problem, it's talking about triangles, and it says which ones must be similar. So we know that similar triangles are proportional, meaning that each side length you can multiply by the same number to get the next side length, but you have to use the same number to multiply, right? Your scale factor has to be the same. And also we know that the angles do not change. So in any triangle, doesn't matter how big or small, all triangles have 3 angles that add up to 180 degrees. So if we look at the last one, oops, I did that again. If we look at the last one, I keep forgetting my highlighter. They're talking about 2 triangles and they give you 2 different angles. So if we consider the fact that there's 180 degrees in a triangle, and the first one, it says triangle 7 has a 50-degree angle and a 25-degree angle. Well, if you add these together and subtract from 180, let's see, 50 and 25 is 75. And 180 minus 75 is going to be 105 degrees. So since we know that 2 similar triangles have to have the exact same angles, we can say that triangle 7 and triangle 8 are similar because their 3 angles are the same, right? If it's 180 degrees and you know 2 of the angles, the third one has to be 105 in this case. And for triangle 8, since they gave us the 50 and the 105, we know that the missing angle has to be 25. And therefore, those are the 2 that are similar. For problem 3, you're supposed to identify all of the lines that have a slope of 5/2. So remember, when we find slope, we're counting, literally counting, rise, which is your vertical change, your up and down, over the run, which is your horizontal change, or the side-to-side part of your triangle. These triangles that they've drawn for you are your slope triangle. So you have to pick points like they did where they go right through the graph. And now we're going to count how long the rise is. Remember, the rise is the side that goes up and down. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my numerator. Rise over run. The run is the bottom part that goes across. So let's see, it's 1, 2, 3, 4. 10/4. Now that doesn't look like 5/2, does it? But if we divide both of these by 2, we get 5/2. And we can prove it on the triangle. I can start at this top point, or the bottom point, but I'm going to start at the top one. And I can count down 5. 1, 2, 3, 4, 5. And go to the left 2, make a run of 2. 1, 2, and I'm back on the line. So that works because 10/4 and 5/2 are equivalent fractions. Okay, so that means that choice A is correct. Now let's check out, let's see, we're going to do the exact same thing with B. We're going to count the rise. 1, 2, 3, 4, that's the numerator. And the run, 1, 2, denominator. 4/2 means 4 divided by 2, which is 2. And 2 is not the same as 5/2, because remember, this is our goal. This is what we're trying to find. So it can't be B. Let's try C. This has a rise of 2. That's your numerator. It has a run of 1, 2, 3, 4, 5. 2 over 5 is not the same as 5 over 2, so it can't be C either. Now, if you notice in D and E, they don't make the triangle for you. You're going to have to make your own slope triangle. Remember to pick points that go through the graph. So for example, this one here, that is not a good point because it's kind of floating in the middle. That is no bueno. That is muy malo. We don't want that. We want one that goes through the graph like this one. That's a good one. Oh, see, this is a good one here. And now we can draw our slope triangle. We're going to go down until I'm next to the point, and then we're going to draw over. And let's count. The rise is 2 over the run. 1, 2, 3, 4, 5. Again, 2 over 5. This is not the same as 5/2, so it's not D, but I did find something interesting. Because these two have the same slope, these are parallel lines. Ah, look at that. This will become important in our next unit, but I just wanted you to see it. Parallel lines have the same slope. Anyway, last one, let's look at E. Again, we're going to pick 2 points. I like this one here. This is a good one there. I'm going to draw my triangle. Notice I'm going straight down and straight over. All right, let's count. 1, 2, 3, 4, 5 is the numerator. 1, 2 is my denominator. That's what I was looking for, so E is the other correct choice. And A and E, because they have the same slope, those are also parallel lines. Okay, so for number 3 was A and E. In problem 4, they're asking you to identify similar polygons, similar to A. So first, let's review what similar means. It means that you have the same angles and the sides are proportional. When we say proportional, it could be bigger or smaller. It just means you're multiplying by the same number, and that number could be a fraction. So I'm going to start out by counting how long each of these sides are for A. So this has a side length of 2, a side length of 2, a side length of 4, and then this weird diagonal one, which is kind of hard to measure, right? I can tell it goes diagonally through 2 shapes, so I guess we can call that 2. All right, so in addition to having proportional sides and having the same angle measurements, similar polygons can also go through series of transformations to get to a new position, okay? But let's rule out some of these. So let's look at B. Let's measure how long some of these B's are, or some of the lengths are. So this one's got 1, 2, 3, 4, 5, 6, 7, 8. Well, I can tell it's in the same position, and from 4 to 8, I know I have to multiply by 2. Right? 4 times 2 is 8. So let's check and see if the other sides all multiply by 2. Because if they don't, then it's not going to be proportional, which means it's not similar. So let's see, going on the the right side, the original figure had a height of 2, so this one, if we multiply by 2, should be 4. 1, 2, 3, 4, that works. The top is 2, 2 times 2 is 4, that matches. And this is going through 1, 2, 3, 4, which makes sense, right? I multiplied every side by 2, which means that choice B is one of our correct answers. Because it has a scale factor of 2, that makes it similar. Good job. Let's check out, let's check out C. So let's measure this. This has 2, this has 1, this has 1, that has 1. I know it's upside down, but can you in your mind flip that over so the 2's on the bottom, right? What can I multiply times 4 to get to 2? That's right, I can multiply by 1/2. Half of 4 is 2, and the other 3 sides were all 2's, and half of 2 is 1. 1, 1, 1. We found another correct choice. We have B and C. Those are correct. those are similar to polygon A. Now, let me erase some of this so I have some room. Let's check out shape D. Let's see, I'm going to use green. The top here is 3. The side here is 2. Already, I'm not even going to go any further. Do you see how these are the same? Well, if those two are the same, that means we're multiplying by 1, right? They all need to be the same, but the 2 and the 3 don't match. So right away, I know D cannot be similar because it changed its proportion. So that one's out. Let me get rid of this. I have my lovely eraser on here. Let's look at F. Same problem is going to happen here. Do you see how the top side is 2 and this one is 2? That means all the other sides should match as well, but they don't. That has a 4, where in my original diagram it's a 2. Okay, the bottom part's also 4. That part matches, but the diagonal and the right side are not the same. Therefore, F does not qualify. All right, so whoever's paper this is, they're doing pretty good so far, right? They got B and C. Good job, you, whoever this was. Let's take a look at E. I know it's turned a little bit, but let's go ahead and count the sides. This has a side of 2. 1, 2, 3, 4. This has 2, and this cuts across 2. Well, that matches, right? Imagine you took this E and you turned it, you rotated it clockwise, 1 turn, 1/4 turn, like a 90-degree turn, and this 4 is on the bottom like in my original picture, and all the others are 2. So that means that we found another correct answer. So this guy, whoever this was, he only got 2 points instead of 3 because there are in fact 3 correct answers. Okay, it says for problem number 5 at the bottom, it says choose one of the polygons that are similar to polygon A and describe a sequence of transformations that take polygon A to the selected polygon. A lot of you went with E for some reason. That one works. You would have to do a rotation. So let's see, if it were E, you would have to rotate, we said 90 degrees, and I'm turning to the right, that is clockwise. And then, let's see, let me get rid of some of this. So we have room now. So if I were to rotate it 90 degrees, my new position, we'll do in green, I'm going to rotate around this. So this is my center. We'll call it point X. So we have to say right around point X because you have to have your center of rotation. Now, if that were the case, then my new figure would go this way, across 2, over 2, down 2. Right, there's my new position for E, that's E prime. Then you would have to translate left. Let's see, I'm going to go with this point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm stopping there because I want to get up here. So you have to go left 11, and then you'd have to go up how many? 1, 2. Now, that's just for the nose, right? But wherever the nose goes, the rest of the points are going to follow. So that would be for E. Now, if you had taken point C, you'd have to dilate first, right? Remember we said that each of those sides multiplied by 2? Or I'm sorry, multiplied by 1/2. So you would have to go in reverse. You'd have to go from C and double all of your sides. So you would say dilate with a scale factor of 2. And then you'd have to reflect so that it's not upside down anymore. And then translate left and up. Wasn't there an easier one? No, I guess not. And then the same thing for B. You would have to scale factor. You'd have to dilate with a scale factor of 1/2 to get it back to its original size, and then translate up and left. Okay, so you have 3 that you could have worked with there. Okay, for problem 6 and 7, we know that similar triangles, and they tell us that they're similar triangles share a common scale factor. And what that means is this number, or any of the sides, times the scale factor gives you the other side for your similar triangle. They're proportional. So 2 times some number gives you 1.34. 2 times some number equals 1.34. So to figure out what that number is, all we have to do is divide. Divide both sides by 2. So I got my handy dandy calculator over here. Divided by 2 is 0.67. So we said that 2 times, oops, wrong one, times 0.67 is how we get to 1.34. So the question's asking you about DF first, which is this bottom part. We already have the 4. All you have to do is multiply times 0.67. And 4 times 0.67 is 2.68. And we do the same thing with our third side. 3 times 0.67. I don't know that one offhand. 0.67 times 3 is 2.01. So those were the answers they were looking for. DF was 2.68 and EF is 2.01. So did you see we had to divide first? We divided 1.34 times 2, and that gave us a scale factor. That told us what we needed to multiply by. Because 2 times 0.67 is 1.34, that means we had to multiply the other two sides by the same number. In this case, 0.67. All right, question 8 was asking you about the slope. So let's figure out slope. So we know that we can do rise over run, but in this case that's not too helpful because there's no graph really. So we would use the slope formula. The slope formula is y2 minus y1 divided by x2 minus x1. That gives you your slope. So all we need to do is pick 2 points, and they give us 2 points. Here's this one, and there's this one. So we're going to call this, because this is my first point, this is going to be my x1 is 6, and my y1 is 10. All the 1 means is that it's your first point. This is my second point. In this case, the 2 is going to be my x2, because it's my second x, and this y is my y2. Okay, did you get all that? Okay. All we have to do now is substitute. We're using this formula, y2 minus y1. y2 is 2, minus y1, which is 10. And in the denominator, we do the opposite. x2, which is 2, minus x1, which is 6. And we subtract. 2 minus 10 is negative 8. 2 minus 6 is negative 4. Remember that your fraction bar tells you to divide, and negative 8 divided by negative 4 is 2. Therefore, the slope of this line is 2. And then in number 9, it asks you to write the equation. We use the formula for slope-intercept form. We use y equals mx plus b. The slope is your m. What we don't know is the b. So what we do to find it is we pick one of our 2 points. We can either use the 2, 2 or the 6, 10. I'm going to use the 2, 2 just because the numbers are smaller. And we substitute. So instead of y, I put in the 2. Instead of the slope, instead of m, we put the slope, which is 2. Instead of x, I'm using 2 plus b. Do you see how I filled in all of the variables with numbers except for b? So that helps us to isolate it. All right, 2 times 2 is 4. I'm going to come down here. So 2 is equal to 4 plus some number. To figure it out, let's subtract 4 from both sides. 2 minus 4 is negative 2. 4 minus 4 is 0. So we're left with b, and we have our, well, the variable b represents your y-intercept. So that lets us write our equation. Y equals 2x, because that's your slope, minus 2, your y-intercept. This is the answer to number 9. finally, number 10, the toughie. There's several ways to figure this out, but I like to use the slope formula to help me. So since I already know the slope is 2, I can use my slope formula. I'm going to use the 0.610, okay? And then I'm going to use, let's go for A first. We'll do A first. So y2, which is 8, minus y1. So here, instead of x1, I have A, but x2 is 8. Okay, 8 minus 10 over, did I do that right? Yes. x1, which is A, that's what we're looking for, minus 6. Okay, 8 minus 10 is negative 2. 8 minus 6, we don't know what that is yet. But it has to equal 2 over 1 because we know that that's our slope. So, because this is already negative, I know that my denominator has to be negative, right? Because a negative divided by a negative is positive, and my answer is positive 2. So, this is already a 2, these match, so I need my denominator to be negative 1. Negative 1. So what number minus 6 is negative 1? It's 5. So A has to be 5. So if we plug it back in, if we substitute it here, we should never say plug it in, sorry. Oopsie. There. Let me erase this disaster that I made. Thank you. Okay. 8 minus 10 is negative 2, so now I'm just verifying that my answer was correct. I said it's 5, so let's find out. 5 minus 6 is negative 1, and negative 2 divided by negative 1 gives us positive 2 over 1, which is 2. And that matches our slope. Now, so that was A. So A is 5. Now let's do the same process to figure out B. So I'm going to use the 10 and the 6 again. Well, the 6 and the 10. We can make this x1 and y1 this time. And now to find B, that's 4, and B, that's going to be our x2 and our y2. Remember, the subscripts, or the numbers at the bottom, that just means which point it came from. So x1, y1, that's the first point that I have, and the second one is the second point. So y2 minus y1, that's going to be b minus 10 divided by x2 minus x1. So b minus 10, I don't know what that is yet, but I know it has to equal 2. 4 minus 6 is negative 2. So let's ask ourselves, what number divided by negative 2 equals positive 2? That's right, it has to be negative 4. Because negative 4 divided by negative 2 is positive 2. So now let's come back over here. B, some number minus 10 has to equal negative 4. So if you can't do that in your head, we can add 10 to both sides, and that will give us B is equal to 6. So let's plug it back in. Let's substitute. No, I did it again. Let's substitute. Instead of B, let's put in our 6. 6 minus 10, it is negative 4. 4 minus 6 is still negative 2, and negative 4 divided by negative 2 is positive 2. So that means that B has to be 6. So there's your answer to the last question.